All right, what's on the bench? A whole bunch of little bags. So I was looking in the box that Mike sent, and in this one bag was all of these parts, and they're inductors, and that's great because I don't have a selection of surface mount inductors. I don't have a selection of inductors in general. I have spotty versions of inductors. I have certain values, but I don't have a good range, a complete set. So this gets me, let's see, this goes from 10 microhenries to 2200 microhenries in pretty fine resolution. 47, 56, 68, 82, 100. So yeah, pretty nice steps. And these are neat little packages. They are, let's see here. Let's pull one of these out since there's a whole bunch of these. So this is 820 microhenries, and it's a little spool. It's a little spool with wire wrapped around it, so it looks just like an inductor. No magic, just wrap a wire. So let me show you this under the microscope. You can see that on the bottom it just looks like a, like maybe a 1210 size part, and it just has a little pagoda shape to it and a whole bunch of little wires wrapped around in there. So that's really all there is to these things. You can do the calculation. There's formulas for how many turns and what type of ferrite material. I think this is probably ferrite, but could be some other type of magnetic material. But yeah, there you go. All right, so let's go ahead and measure one of these. So they're surface mount. So I took one, if I can zoom down again, I took one here and mounted it to a little board that I have. And we will stick it in the machine and see if it really is 820. All right. Oh, we zeroed out to 63 femtofarads. That's a pretty good zero, isn't it? But we're going to be measuring inductors, so let's push the L button, okay? And we'll put in the part. And let's see here. We don't want 100 megahertz. Let's go down to 10 kilohertz. And yeah, there we go. 822. So pretty darn close. So 822 microhenries. And we can also measure other things, like its resistance. Its resistance is 200 ohms, and its impedance is 53. And if you take 200 divided by 53, you should get the D value. Let's see here. D value is Q value. I'm sorry, Q value. 3.6. So 200 divided by 53 is 3.6. So that's how you get that number. And there are other numbers. You can take the arctangent, and you can get things like let's see here. You can get the theta, which is 74 degrees. That's the phase shift of the electrical signal through there. Eli the Iceman. So Eli electricity leads inductance in an inductor by 74.48 degrees. So yeah, there you go. But indeed, we have 82 microhenries. 820. So let's go up in frequency, and this should start to drop here. This is 100 kilohertz, 200, 400, 1 megahertz, 2 megahertzes, 4 megahertzes, and then it's not working any longer because the phase shift probably was all whacked out. But yeah, there you go. And these machines will measure, like I said, the DC resistance and then the AC resistance, which is the absolute value of the impedance there. And yeah. So almost all of these parts, in fact, all these parts except one are from NEC. So these are all Japanese parts. And that's the part number there. That's for a 447 microhenry. 40 pieces each. So it must have been some kit that he came across. He likes to buy things at auctions, so he probably bought a big box of these. I don't know. And then there's one that needed, I guess, replacing, or a value that he didn't have. I don't know what it is, but this one is from the Murata company, the 820. But all the other ones look the same too. They're all the little pagoda-shaped things. Guy's name? Mecca? I don't know. Interesting. Anyway, thank you, Mike. I now have a whole bunch of surface mount inductors. How nice.